Hello everyone. Today we'll check out what is stack and how we can implement stack in C++. So firstly we'll go through some theory part and later we'll check it in the code. So yeah, let's just check the theory. So what is a stack? So let's say we have a bucket here. I'll just draw it nicely more. Yep. And we need to put some data in this bucket, right? So it can be like sequential. So firstly, one data will put, let's say we have put one here, integer data, then next data will come on top of this, so here we'll put 2 and later we'll put this way it will go, so it will be like on the top we'll be putting new data, so 3, similarly 4 here, so like that we'll be putting data. Stack itself is not a data structure. We need to use an underlying data structure kind of concept to implement this stack. So it can be linked list, it can be an array, so we can use anything. So basically let's say we have an array, we'll use array for this demo. So let's say we have an array of maybe 1 4, let's say 5 2 maybe. So here we have this data, so we need to put this data in a stack. So how it should be? So firstly, the first data will be pushed to the stack. So first data is this one, right? 1. So 1 should be pushed here. So 1 came here. Then we'll push the next data that we have, which is 4. So 4 will be pushed here. Similarly, these two will also be pushed here. 5 and this last one, which is 2. So we have this. So this is our stack. So that's how we stack one data on top of each other. As you can see here, we have 1, then on top of it we have 4. Similarly, we have 5 on top of 4, and lastly we have 2 on top of 5. So this represents the top currently, because it is at the top of the stack, this 2, because on top of 2 there is nothing. So 2 is the topmost element, you can say. So that's what stack is, mainly nothing much, just imaginary stuff, you can say, just to arrange the data that we will be doing. That's it. So how to implement stack, what kind of features a stack can have, we'll discuss about that. So what is the first function a stack should have? Firstly, we need to push the data inside of the stack, right? It is currently nothing, empty. So we need to push the data. So the first function will be push, and so let's push the data, all the data. So 1 4, then 5, then 2. So all the data is pushed. Now we need to remove also, right? That is the point of stack. We can push and also remove. So remove, we can directly maybe give it a word, let's say pop. Pop means remove the data. So we pushed it in a sequential order, right? So first 1 came, then 4, then 5, then 2. Similarly, when we pop or when we remove a data, the topmost element we should remove always first. So this one will remove first, and then if we call our function, this is pop, again the 2 got removed, right? So 2 got removed, then again we called this pop function, so again this will remove the top element. After 2 got removed from the stack, the topmost element became 5, because before that 2 was there but it got popped, so the top is now 5. So 5 is the topmost element and it will also get popped, right? So if 5 is popped, then 4 becomes our topmost element again, because 5 was on top of 4, but 5 got popped, right? So now 4 is the topmost element. Similarly, once we pop 4, 1 will become the topmost element, and when we pop 1 also, our stack will be empty. So that's the concept of push and pop. mainly these are the main functions we use in stack. We can also have other functions, let's say maybe peak function, which will give us the topmost element present in the stack currently. So that's it. That's these are the functions that we'll use: push and pop. So we'll just remove this. Now push pop will see, and also peak will be checking how to do peak. Peak means to check the element, topmost element present in the stack. Or we can have peak all function, which will give us the overall how many elements are present in the stack. This also we can do. We'll check that also in coding. So now we have our array here, and we need to organize it using in a stack format, in a stack way. Now how should we do it? See, we discussed about push and pop, right? So these are functions. This does not define how we can create a stack, right? These are just functions that our stack should have. But this push and pop does not tell us how to create a stack. So how do we do it from this array? So firstly, we need an what do we need here? Firstly, we need one variable to check the top function, right? What element is in the top that we need? Because if you can see, uh, when we execute push function or pop function, I'll put these elements again back, 5 and 2, right? So when we execute this function, let's say we execute pop function, it needs to check the topmost element, right? Then it needs to remove that element. So my point is, like, how should we know what is the top? So for that we need to have a variable, right, to know that what is the topmost element currently. So we'll have a variable called maybe top. What else do we need here? After top, what else do we need? We need the capacity also, right? See, our stack cannot be like infinite. It is not possible for a stack to be infinite, for anything to be infinite. So our stack should have a minimum capacity, like maximum capacity, after which it should not push any element. See, if our stack's capacity is 3, currently here is 1, 2 and 3. 1, 2, 3. So only 3 elements can be pushed to the stack: 1, 4 and 5. After 1, 4, 5 we cannot push 2 because there is no other space in here. Our capacity was 3. So our stack should also have a capacity variable or element, we can say. So top capacity variable, and also what do we need? See, this is an array, right? We need some underlying data structure kind of thing to create a stack, right? Either it is an array or it is a linked list. We need something. So let's just have array, because we are using array for this example. So we need these 3 things to make a stack. So how do we do these things? So that is the concept of stack, nothing much. So basically we need these things. These are the building blocks, you can say, or raw materials that we need to create a stack. And the push and pop would be like the interior design, you can say, maybe, or something. These are the things that defines the characteristics of the stack. So top, cap and array we need, and this is our data that we have, 1452. So let's just try it in the coding. I'll be using C++, and you can use any language that you prefer. So let's just run the boilerplate here. So we have the boilerplate. This is not required. So this is the C++ normal boilerplate that we have. Now we need one array, right? Okay, let's just create one function for now. Not function. Firstly, we need a structure. to define our overall structure, right? This is a structure that we need. So let's create a structure. You can also use class if you want to use that. Okay, that should also work. Structure, let's give our structure name as stack maybe. So this is our structure. Yeah. So what do we need inside of our structure? We need the three things, right? Like the raw materials that we need. So top, cap, and array we need. So firstly, it's the integer kind of stack, so it should be integer top. We'll initialize that. Int cap also we need, and we need an array. The array should be empty right now, right? Like the initial stage of the stack should be empty. Then we'll push the values or the data that we have. Firstly, the stack should be empty. So our stack is empty here. So this is our initial state. So top is nothing, cap is nothing, just initializing, and we need one array. So maybe we can. The array should also be like for now we have the integer array. So like we'll just keep the data type as integer. Maybe we need one pointer here. I think int array should work. Yeah. And so we have the stack layout here, this structure, but we need to call this, right? There is nothing currently. These are nothing. So we need to have a constructor for this. So it should be directly stack, similar to a function, how we define a function, same thing. So we have this, and inside of this we can give something to these things, give some value. So at initial stage, what should be top? It should be see, our array starts from 0 here, right? The index of array starts from 0, 1, 2, 3. As we are using arrays as a underlying data structure to create this stack data structure, so we need to follow this. So here 0, 1, 2, 3 is the indexes that we have for our data. So what should be top? Top is the empty, right? So if our data starts from 0th index, the index will come here, data will come here. So 1, 4, 5, 2 we have, right? 1, 4, 5, 2. So index is 0, 1, 2, and 3 index, right? All like these are the indexes that we have. So at initial stage, we don't have these data, right? We have an empty array, so we don't have any data. So what should be our index? Below this, right? Below this, what do we have below 0? It is -1. So our top should be -1 when the stack is empty. So when the stack is empty at this stage, our top should be -1, because there is nothing in the like nothing in the stack here. So as our stack starts from data pushing starts from 0th index, so what is before 0? That is -1. So we will have -1 as top. So we can maybe give it here, top equal to -1. You can directly give. Top is done. Now the capacity we can pass actually. We'll pass it from here. We'll initialize the array. Okay, firstly let's initialize the array. What So let's initialize an empty array. See, the first at the first thing, our array should be empty, right? This we are representing as an array, this stack. So it should be empty. So firstly we can do can we use array new int? Hopefully we can directly use this. We are using a pointer, so this is not required. It's not allowed, so we can maybe give something. Yeah, so this will be the capacity, but we'll not pass it here because we don't have it right now. So what can we do is we need to create an object, right? This is similar to class, so directly we cannot call this. We need a object for this. We need to create an object. So stack s we can maybe give, and let's just pass something here, maybe cap equal to 6, maybe we can pass, and s of will pass 6 here. Directly cap we can pass. So cap we are passing here, capturing here, and here it should be cap. So now what do we have? Okay, our array capacity is done. I don't think we need the cap because we are directly passing it from here. Okay, whatever, just have a cap, no problem. Cap equal to, we can maybe give it capacity as we are passing cap directly. So okay, just keep it cap, and we'll pass C rather than cap. We'll pass C here, C here should be C. So C here is 6. That means our capacity we are defining here, and we are passing 6 to stack. Stack is taking the C, and stack is making C as the capacity, and this capacity we will use directly here. So now we have everything initialized. Top is currently -1. Right now our stack is empty, so top is -1. Cap equal to 6. We are defining the capacity as 6, so 6 is not equal. Let's keep it 4 maybe. We'll use the same these values, this data. So we'll have the capacity as 4. So 4 we are passing here, and 4 we are setting as cap, which is the capacity of our stack. Similarly, we have array. This is a new operator that we use to create a variable kind of thing. So right now it is an array which is a type integer, and we had the pointer here for the array. That's it. It is just creating a empty array of type integer with a capacity cap here. So now everything is done. Currently our top is -1, cap we have set as 4, and array, the empty array is done. We have an empty array. As we are representing this stack as an array, inside like underlying it should be an array, so we are not writing any arrays like this here. We'll directly push the data. So this is done. Now we need the functions, right? To push the data, you need the push function, or else how you'll push the data. So we need to have functions. So we'll define functions here. Maybe push function. Maybe pull function, pop function. So we talked about these two functions, push and pop. Let's also have the peek all function, which will tell us how many elements are there in this stack currently. So we have these three functions. Let's call them outside of our structure. Maybe type is void, and it belongs to stack. Function is push. So we have the functions, three functions, right? So push, pop, and this one. I'll just copy from here, paste it here. So I'll copy here, paste it here. So this is done. We have the blueprint, or what can I say, boilerplate of the functions here. Now how do we do the functions? How do we push the elements? So to push something, you should call this, right? So our object is what? S. So s dot, see, we have the functions ready here. So first is push function. We'll give maybe same values we can give. Let's give 1. So see, we are getting error here because see, our push function is not accepting anything. So if we are pushing something, we should have the data here, right? So we need to pass the data. So s dot push should pass something to here, um, to the functions. So the type is integer, and let's maybe something x we can give. Similarly, we need to copy and paste it here because this is the main functions where we'll write the function. This is just a definition that we are defining here. So our push function should accept the data, which is it is accepting. And now we can write something. Firstly, we have to check. What do we need to check to push? See, the first thing I said is like if our stack is full, our capacity is 4. So if our stack is full, it should not allow any data to be entered to the stack, right? So if top equal to capacity, then cout stack is already full. Now else what should happen? Else will increment the top, then we'll push the data. So where we will push the data? We'll push the data to the array, right? This is our array. So we'll push the data array of top equal to the data that we have passed. So x, and then we can maybe cout it. Uh, data x got pushed to the stack. So that we can do. Maybe we can do handle. So this way we'll push the data. So this, our push function is currently done. And so let's have one peek all function also. Let's just initialize this so that we can see that our okay, we'll run this and check if it is working. Just yeah. So I'll run this. See, and we can see that data 1 got pushed to the stack. So currently our limit is this, right, 4. So let's push some things also. So 1 4 5 2 we need to push. So let's push those 1 4 5 2, 1 4 5 and 2. So this is our data that we will be pushing. So if we run this now, we can see that 1452 got pushed to the stack. Let's try to push something else. Maybe let's try to push 3 and see what happens. So we have 3. So let's push this and see what happens. 3 got okay. So this is not working properly. If top equal to cap is 4, we're incrementing top here. Let's just maybe cout top also so that we'll know what is happening. So yeah, so our capacity is 4. Okay, yeah, it should be cap minus 1 because this starts from 0, right? So our capacity as it is start from 0, it is starting from minus 1. So our cap should be here 3. So what that means is once the data got pushed to the stack, so let's say 1452. So here our top is what? See, here our top is 0, right? Because initially it is -1, then it became 0 when the first data got pushed. So similarly 0, 1, 2, 3. So here at the end our top should be 3 here, because it is starting from 0 when the data goes pushed. So when the top equal to cap -1, then we are saying stack is full. So if we run this now, we can see that, yeah, I'll just remove the top here, and when we run this, we can see that 1452 got pushed to the stack, and then when it's the time to push 3, it is saying stack is already full, because it is meeting this criteria here, where top equal to cap -1. So our capacity is set, and more than that it will not allow to push into the stack. So this is now done, and let's just write the pop function also. So what should be our pop function now? We have pushed this element, right? So we need to pop also now. So this elements got pushed. I'll just remove these things. 1452. So what should happen when we run pop? When we run pop, it should remove the topmost element, right? This one should pop first. This one should be removed first. And this one should be removing. That's it. The topmost element will be removed when we run pop. That's it, nothing else. So how do we do that? So this is our function for pop. See, pop should not accept anything, right? In pop, we are not accepting anything. We are just removing the topmost element. We are not pushing any data, so we don't need to have any data. So that's why there is nothing in this argument. We are not getting anything here. So how do we remove? So firstly, what should it check? So once every element it got popped out and our stack became empty, so if there is nothing here, should the pop function work? No, right? Because there is nothing to pop out of the stack, nothing to pop out. So how the pop function will work here? It should not work, right? So we need one base condition for this also. So what it should be? It should be if array if top equal to -1, then cout stack is already empty, hence no element will be popped. So if this does not work, which means we have elements in the stack, so we need to remove, right? If we have element and we run this pop function, it should remove the topmost element from the stack. So how can we remove it? So once the data got pushed to the stack, the indexes becomes 0, 1, 2, and 3, right? These are our these are the indexes that we have for the stack elements. So how do we pop them? How do you pop this? So what we will do is we'll have the array of top equal to, we'll keep it null, which means what? See, currently our top is this, right? Because this is the topmost element. So array of top equal to null. This means this is getting null. That means this data is corrupted now. The data is garbage now. And then we'll do top minus minus. So what was the function of our pop? What is the criteria? Like, what is the characteristics of our pop function? The characteristic is that when the pop function is called, it should remove the topmost element and it should make the next element as the topmost. So once 2 is popped, 5 should be our topmost element, right? So top minus minus will reduce the top from 3 to 2. So this becomes our new top. So once that function got run, this got garbage, became garbage, and our top came here. So our top is now 2. So this is nothing. So that is done. That means our push and pop functions are done, which are the actual main functions that we have in a stack data structure. Now the peek all function should give us all the elements that are present currently in the stack. So how do we do that? It also should not require anything to pass, because it just needs to print out whatever the elements are there in the stack. So how do we do that? For example, we'll take one loop for that. For int I equal to 0, I equal to top, I equal to 0, it will be starting from 0, right? I equal to 0, I is less than equal to top, I plus plus, and then what it should do, it should see out array of I, and then this will give one handle also. Now when this function will run, it will give us all the elements currently in the stack. So our stack elements should start from 0. If it is -1, it is nothing, right? The stack will be empty. So it should start from 0 if we have any data. So 0 to where? Wherever the topmost element is currently. So our topmost element is currently this, because 2 got popped out. So when we run this, it should give us the elements that we have. Uh, should be, okay, it's not actually, um, yeah, so stack is already full. Yeah, so we have 1, 4, 5 and 2, and okay, it should give us int I equal to 0, I is less than equal to top, I plus plus. So it is not working properly, the p call function. So let's analyze what is happening here. So let's just remove this for now. So we have pushed the elements, and this is the last one, so it should remove first. I mean, it should just see, we don't have any pop function here, right? We are not defining, we are not running any pop function, so it should give 1452, and it should be fine. See, it is giving 1452, so it is fine, no problem, it is working fine. So let's just pop something now. We can directly call this, and then we'll again peek all to see if 2 is getting removed or not. See, so when these run, 1 got pushed, 4 got pushed, 5 got pushed, 2 got pushed to the stack. So after when these 4 lines ran, this is our structure of the stack. Fine. Now we have a pcall function running, which give us 1, 4, 5, 2 elements it will give. Now we have ran s dot pop. So this got popped, and then we ran this s dot, we called this s dot pcall function, we again called. So when we again call, it should give us 1, 4, 5, because 2 got popped out, and 5 is our current topmost element. So we have some error because of this file. Just to change this file. Yeah, so we'll run this again. Maybe we can add something here with the cout, so that it will be clear in the output. Maybe we can have one handle also for this. This is below are the latest output, maybe we can mention, so we can see what is happening. So we can see 1452 got pushed, so this happened. Then we have output of our current stack, which is this function. After that we have this, which is this, and then we have again we have one pop function which popped one element, so 2 got popped, and our current stack is 145, and then we ran this, right? So it gave us the output here 145. So that's the overall stack. That's how we do stack in C++ or anywhere, like in any language. But we don't need to design the whole stack ourselves. We can directly use the inbuilt libraries that we have. So for C++, if I can just okay, I'll just use this previous boilerplate. So I'll just remove these things not required. These are also not required. So this is the main thing, right? Just the C++ boilerplate that we have, default one. So now how do we use stack here? So firstly we'll have to mention the header here, or include the header here. So header name is stack directly, and what we will do here is we'll write stack and then the type of the stack. Currently we in this example we are using the integer type, right? So we'll have an integer type stack, and the object that we need. So previously we used s, right? S object. So similarly we'll use s here. We can give anything, like maybe whatever the stack name, we can give anything, no problem. And directly we can use, so s dot, so we have the functions directly here: swap, top, size, whatever, all the functions are there. So s dot push 1, so this will push 1 directly to the stack here. So similarly let's do the same example here. So 1452, so 1452 we have, and then we removed them, right? So if we do this, we'll not get any output because this does not return anything. So inside of these functions, inside of this stack, there are no couts, so we don't get any output. So we have to specifically mention the cout here. Should work, but why it's not working? No operator matches these operands. Okay. We cannot see out this. I start push should work, but we cannot for some reason. Okay. Okay, fine. We don't need to capture it here. We can capture it later, maybe. Okay. For, can we use for loop to check? It's less than equal to s dot top. Maybe you can mention s dot top I plus plus cout array of I. So this should array will not be giving like that. So how can we? We don't have the array here, right? Because it is inside of this. Can we use directly s here? I don't think we can. Um, it should be capturing C out, but I don't know why it is not capturing. Operator. Yep. Just check this. Maybe. No. All right. Let's just maybe check if pop is working fine or it is also having issues. Let's see what happens actually. Um, no type named in false void. Okay. How do we capture this then? Hmm. All right, let's just directly run this and check what happens. So we need to run this, right? And then we need to check the topmost element, whatever is there. Currently, our stack is having topmost element this. So we can directly use as dot top. And I think this should be having C out. This should the C out should work with this. Uh, yeah. So let's not pop anything and see what is the topmost element currently we have in the stack. Okay, it is, top does not have a name type. Okay. Should work actually. Hmm. Yeah, you can see that we have the 2 as the current top here. So now if we pop something, our topmost element should be 5, right? So let's pop something. There's some issue. Yeah, 5 is there. The code runner is having, the temp runner is having some issues. So if I do this, it will run only this part, I think. Yeah, that's why it was having issues. So yeah, fine. The code should work just fine. If we can see, our output is now currently 5 because 2 got popped here. And if we pop again before printing anything out, so we popped twice, right? So this element got removed and then this element also got removed. So our current top is 4. So it should give 4 here. See, it is giving 4. So which is fine. So that's how we do stack mostly. That's how we use stack in modern C++. We don't need to design anything. So that's about it. We can directly use this stack data structure, which is already present in the standard template library of C++. Either you can manually write the structures yourself, or you can use the built-in library that we have. Because this is quite easier, because you are not doing anything, you are just defining the stack here with an object, and then you are directly using the push functions, push, pop, everything. So that's what stack is and how you should implement stack in C++. We'll in the later videos which I'll be putting, we'll see the quicksort using stack, because quicksort we should not be will not be able to do using iterative method, as quicksort is like breaking down something into different parts. So it will be like this. If I can show you if I can tell you a demo or maybe a brief about quicksort. So if we have something, it will have one point and then it will divide uh, the stack, like the array, let's say, into two parts, and then it will swap those elements, and then it will again merge them to get the actual sorted array or sorted structure. So we'll check that out using iterative method. For that we'll use stack, and or else we can directly use recursion for this, which is the main method which we use for these types of algorithm. So I had to do one stack video because of the quicksort one. So thank you. Yeah.